We are going to talk about how to make sense of all of our compute pieces, where to run your stuff, give hopefully a good lay of the land of where things are at. I was talking with folks ahead of time, a bunch of data science related folks in the room. I'm not going to talk about anything machine learning or data science directly, but about the platforms that run a lot of that stuff on our system, so it might be useful there. So let's get going. So the key question, where should I run my code? And unfortunately, the answer is, it depends. Thus, we have a whole talk about it. So let's get into it. At a really high level, I'm going to talk about 5 different products. And I was talking with folks, I think half the challenge in getting started in Google Cloud is actually just so many names of all of the things. There's like a couple hundred names you need to learn just to kind of make sense of all the parts. So these are the names we're going to talk about today. And starting at the top, we have Cloud Functions, which is functions as a service. App Engine, which is for taking a set of code and running that as a website, usually. Cloud Run, which is new, and we'll talk about that in details, like announced today. Kubernetes Engine, which is a hosted Kubernetes cluster. And Compute Engine, which are virtual machines, network and disk running there. So just out of curiosity, how many people heard of containers? Sorry, thank you for raising your hands. And serverless, and everybody has a different definition. We have 100 people here. We probably have 100 definitions of serverless, is my guess. So my operating general definition here is mostly around the kind of operational model of you pay for the actual usage you get. The infrastructure itself is managed. You focus on your code, that sort of thing. There's another angle as well, though, that I think is interesting, and we usually take these directly together. And there are cases where we can tease these apart a little bit, and is the programming model itself, what it looks like from a developer standpoint. And most things that are serverless are not actually storing state between function calls, right? You have side effects of your code or return values of the functions. Usually kind of a hosted service. Event-driven is a word I'm going to talk about a bit more, but usually there's something that causes it to happen. A request comes in or an event fires. And we're trying to make these more and more open so that you can run them in lots of places. And I'll talk about that a bit. OK, so the key question here is there's so many choices. Am I going to make the right decision? Like kind of decision paralysis sort of thing. And I get there. And my goal for the talk is really 2 things. We kind of get a big map of the territory about what these pieces are, and relax a little bit about the risk here. I'm going to try to make the case that it's fairly easy to move around after you've made a starting decision. So no worries. And at a really high level, and this is the kind of able to move up and down, the top 2, you're mostly focusing as a developer on the code you write. The actual function signature, what returns from it, or the URL maps to different parts of the code, that sort of thing. And down here, we're mostly focused on building a runtime environment with the right binaries, the files it needs, the container of the code itself. And then at Compute Engine, we're looking at a whole operating system. They're virtual machines. You can install anything you want on them, that sort of deal. So just going to go all the way through all of them and move kind of quick and then circle back around. So Cloud Functions, when you're using Cloud Functions, you are writing just one function. And it maps usually to a URL, but some kind of event that comes in. And as a developer, you just think about what inputs, what side effects, and what outputs. And that's the whole world while you're thinking about that function. The events can come from a lot of different places. It's very common for them to come in as an HTTP request. But in cloud, more words, PubSub is our messaging bus. Cloud storage is an object store. And then there's a few other options as well, like hooks to Firebase and the like. And these are fully managed. You just write the code, hit deploy, and it scales up and down, and you pay for exactly what you actually use. Nothing more, nothing less. And it auto-scales with actual usage. So the idea is, hopefully you can just concentrate on that one part of the world and not worry about anything else. So when you're using these, you are thinking about doing system design. You're thinking about what events are going to cause the function to execute and what it does. So that's the mental space you're in when you're working with functions. And I mean, it's the classic definition of serverless in a way. So it's a good fit for things that are serverless. When you're making integrations between other pieces, events are coming from PubSub or storage. You can set things up so you send a new object to a cloud storage bucket, and that causes a function to fire that does something to it, maybe makes a different version of it, copies it somewhere else, that sort of thing. And it's used sometimes in ETL processes or transactional things where you need to, for example, in the storage example, every time a new item goes in, you do something to it. And then my favorite kind of mental model is just thinking of these are the glue of the web. This is the HTTP glue that connects everything together. On the constraint side, you are seeing the entire world through this function granularity. And so as you build more complicated systems, you piece together more functions to do that. And that works pretty well. And then at a certain point, it might be hard to reason about. Or it might be more challenging to monitor or troubleshoot. And so pay attention to that. And in Cloud Functions, there are kind of only specific runtimes available. So if you're writing in those languages, awesome. If you're not, you might not find them as useful. So what does this look like? Let's see. Look at Cloud Functions. Actually, let me just go to the top a little bit. This is the Google Cloud Platform web UI, looking at a specific project. And in my opinion, this is the single most important thing, the hamburger button, because it gets to all the other pieces. If you don't find that, it's really hard to do anything. But if we come in and look at functions, I've got several functions set up. And let's go ahead and use Node, because I think a lot of folks are using Node JavaScript-based functions. And this one's already built, so it's got some source code. And all it's really doing is saying, for every request that comes in, let's look for some stuff in the message body, or in the request, or in the body. And if I don't find that, just use hello world and return that back out the function. So this is kind of hello world of functions. And it automatically gets a URL, and you can map additional ones. But if we run this, we get the default input. OK, but I wanted to do something different. So there's this testing window over here. So we can actually kind of simulate giving it a body in a post request as part of the post. And so we go message. And hello, lovely next peoples. That's you. And we run the function, and we get a different output. So yay, proof that it's real. Additionally, we can view the logs, because the actual execution logs and any log messages you emit during the function call go to Stackdriver logging. So you can see them all in a central place, and the like. So it's a very, very quick taste of what that can feel like. And of course, you can also do that through the command line or via APIs as well, just kind of the web interface to it. So why would you pick Cloud Functions? So a big part is you don't have to think about the infrastructure, the servers at all, like classic serverless, and this granularity of payment. So if you have things that are very spiky or you don't run very often, they will be extremely less inexpensive. I'm trying to avoid saying cheap. They'll be very inexpensive all the way, if you're not running them very often, and then can scale up to lots of load, right? And it's a very straightforward developer experience. You've got your code, and it runs. OK, deep breath. And now App Engine. So App Engine takes the code focus, but goes out a level to think about a whole application. So we're talking about usually a web application, because that's the sweet spot for App Engine. And so you'll have your URL mappings of this URL calls this code, this URL calls that code. Maybe there's some shared code. There's a whole kind of structure of the application that's all one piece. So that's kind of the way you see the world when using App Engine. Again, no servers to manage. It scales up and down really fast. But it has some additional features like versioning of the code base. And then you can do traffic splitting across those versions. So as you do a new release, you can say, oh, I'd like to give a small amount of traffic to the new release. And then, oops, roll that back, that sort of thing, if it doesn't work out. App Engine has been, it's existed longer than Google Cloud itself has, actually. It predates GCP. So we have, it actually has 3 different execution environments. There's a classic kind of standard edition. And there's our newer second-gen runtimes. And additionally, you can actually use the same view of the world and have the code deployed to VMs. And that's called the flexible environment. So there are some differences between these environments. If you're starting new projects, I highly recommend go straight for the second-gen pieces. If you need to, for example, if you need to listen on ports to do WebSockets or something other than HTTP, you need other than short HTTP, you can do that on the VMs. If you need certain machine sizes, like if you need a really particular big machine size, you might go to Flex. But by and large, people are running in the second-gen standard nowadays. And in this space, the runtimes are actually open source. They're written to be idiomatic. They should feel like the programming language you're using. So it should feel like Python to Python people and feel like Node to Node people. We have the set of supported runtimes. There will be a talk at this event talking about a new alpha for our Ruby runtime, for Ruby folks out there. And you basically call GCP APIs directly, whereas in the original App Engine standard runtime, which predated the rest of cloud, there were a lot of kind of built-in APIs for things like Memcache and other things. So when you're using App Engine, you are primarily thinking about your code base, the HTTP requests that come in, like what URLs and where they map, that sort of thing, and different versions of your app, kind of for going forward and back. In fact, you can actually even break the app up into modules if you need to. But that's the primary mental model you're in when you're using App Engine. So it's a great fit. Its natural sweet spot is HTTP web request response applications. There's an execution timeout, so you can't do really long running things, but it's meant for these kind of back and forth request things. It scales very well, both down to run to 0 instances of your backends running, all the way to very high. So a lot of folks are using it in advertising, for example, where you have almost no traffic until an ad thing runs, and then it goes really, really big, and then it drops back off, or maybe kind of long tails out for a while, but you need to leave it up, only paying for what you're using. Again, there are only certain runtimes available, so if you're running in those languages, you're going to be happier. You might not be able to use it if not, and it is the window to the world is the web. That's how it sees everything, is through HTTP. And on the flexible side, it can run anything that fits in a container, but it's running on VMs, and they don't scale quite as quickly. So we need to leave a few running so it doesn't scale to 0, and it takes a little longer to respond to new traffic coming in. By the longer, I mean like minute-ish, couple minutes kind of territory, rather than seconds or sub-second kind of time frame. So you might choose App Engine because it lets you just focus on your code. Maybe your organization is primarily developers, that's what you care about. Or maybe for this particular app, you don't want to invest the ops into it because it's not your core thing. So the part of your system. It's very much optimized for web-focused workloads. And it's especially good for things that vary a lot over time. And this stat is probably out of date, but I couldn't find the newest one. Definitely lots and lots and lots of traffic on App Engine as a whole, and we can handle the load that you've got there, is the point to make there. OK. So now, actually, we've got a new thing. And there is a talk later today that goes into the details of this. This is Cloud Run. And what we're trying to do, like if you look around the internet, there's a lot of like serverless versus containers kind of conversations. Like which one do you do? Like they're in a duel to the like end of time or something. And we're trying to bring these together more like, like peanut butter and jelly or some best buddies or something like that, right? So we're trying to give serverless kind of agility, that pay for what you use, the scale up and scale down, to nearly anything you can put in a container that listens on HTTP. So what it is, you give it a URL to an image that has some code in it that will listen to HTTP on whatever the port environment variable is. And in return, you get something that like scales up and down very quickly. You get the SSL termination, the HTTP request binding through all the load balancers and the like. And a really nice thing for efficiency is that it's not just single-threaded. You can actually, if you're running Java or you're running Go or something that has really good concurrency, you can actually handle multiple requests from the same binary execution. And so if you're writing something that actually has to wait on other network calls, you can actually get a lot of efficiency there in what you're paying for. And scales up and down really fast, and you're paying very, very precisely for the CPU and memory you're using, down to like 100 millisecond granularity. That's the hosted, fully managed version. With the same developer experience, there's also a backend that runs on top of Kubernetes. And so you can deploy things in the same way, have all the load balancing and everything set up correctly, the service endpoints and everything hooked up. But it's part of a Kubernetes cluster you already have or that you're trying to build out on your systems. It deeply integrates with the policy and control you're already running there. If you need custom hardware, you need specific kinds of accelerators like GPUs or TPUs available, you can do that. And because it's running on top of Kubernetes, we can actually run this in a lot of places. So essentially, we're trying to, if you're coming from the serverless angle of not thinking about backends and you want to just have more options, think about the fully managed Cloud Run. If you're coming at this from, I want to offer serverless to the people who are using, serverless experience to the people who are using my Kubernetes cluster, then the running on top of Cloud Run angle, or sorry, on top of GKE angle makes a lot of sense for Cloud Run. So same developer experience, two different backends. You can move between them just by redeploying. Same app. So you can start in one place and just redeploy to the other and go. OK, so let's try to make this real. This is the Hello World app, so we're not going to go too real, but it is real. So we're basically, sorry, let's start at the beginning. We're back at our project top. Choose Cloud Run. And then we'll go straight to create service. It includes a handy little URL to an image that's known to work. So I'll go ahead and paste that in. I'm just going to call it hello, US Central 1. And here's where you can set some more information about how much memory you're going to give to it and how many requests you'd like each instance of the software to handle. So if you've got a single-threaded app, you can set that to 1. If you can handle more things at the same time, you can set it higher. So we go ahead and hit create. This is doing a bunch of stuff in the background, actually deploying the containers, configuring load balancers, like making sure we've got SSL and all stuff set up. This is going to be the URL to our app. If we click on it, it doesn't work right now. So yay, it's actually real life. And something that might be a little bit surprising is if I put my cursor in the lower right-hand corner, the screen turns off. That was probably not expected. The YAML, like under the covers, there's a YAML file to describe this. And it is based, if you've done a lot of Kubernetes stuff, you might have seen these configuration files before in YAML format. And this file, you can take this and run it in other environments. So you don't have to care about it, but you can take this full configuration and run it other places, which is pretty fun. OK. And it says green checkbox. So let's try to refresh this. Forbidden. What did I do wrong? Let's refresh all the things. Is this the Chrome thing where you need to like control refresh? Oh. Demo fail. Oh, see, I'm not authenticated. Thank you, member of the audience. I didn't check the box for actually authenticating this. That's not going to work very well, is it? For leaving it wide open. I did that wrong. Let's deploy a new revision. And no, we'll go all the way back and just make a new one. This is speaker being stubborn after making a mistake. This is the box that I should have checked. Thank you. And we will grab this URL. Give it a new name that is awesome, and hit create. OK. So while that's going, I'm going to give you a sneak on the next little bit. So when you're using Cloud Run, you're thinking about building the container environment for the processes you have. So you can run any language you like. Anything that will run on Linux in a Docker container, you can run that understands how to do HTTP. So you look for the environment variable port, you open a listening socket on that port, and you're good to go. It is, however, stateless in that there's a local file system, but that's actually in memory. And so between invocations of your app, it just goes away. So you can't store a lot of stuff locally, and you shouldn't, other than maybe cache if you have to. It's mostly there for compatibility with libraries that expect it. So you should think everything that comes in and goes out. Let's try to go back and see if we got a new URL now, deployed just now. Moment of truth. It's running! Yay! Thank you. Thank you, members of the audience, and supporting me in this really alive demo thing. OK, so this is a good fit for things that are stateless. Again, HTTP request response workloads. That's how you talk to it, is through the load balancers over HTTP. It can handle bursty traffic. It scales down all the way to 0. You pay for exactly what you use. And if you have a scenario where you really need specific runtimes or languages or binaries around there, because it's not just the code you're actually writing. You could include other things that you shell out to or whatever you need to do in that Docker image to solve problems. If you've got some really gnarly stuff that's been around the office forever, like if you can put it in a container, you can put that on the web, make it feel serverless. On the constraint side, it is, again, containers. So it has to be in a container to run it. And because we're getting a little more focused here, how you build those images is up to you. So it depends. Like, you have to decide how you're going to do it. We have Cloud Build. There's lots of other CI/CD tools out there. Anything that results in a Docker image in a repository that has the other things like listens on a port and stuff, you can use in here. So why would you use it? If you want this developer experience, this kind of serverless developer experience, you have the option of having it be fully managed or deeply integrated with Kubernetes. And you can decide later at ops time, even a different group of people, what that deployment environment actually looks like. So you can do all of your dev work in one and then decide later to switch to the other just by deploying the code. And you can run basically anything that runs in a container over HTTP. And then I got a new word that shows up here at the end. I'm claiming open and Knative, Kubernetes. So you can actually run these same images on Knative on top of Kubernetes anywhere that Kubernetes runs. So if you want to run this on your own machines, you've got your own data center, you're in another cloud, you want to run it in all the places, you can take this same runtime environment and run it in all of those and make that decision at deployment time as well. So there's Cloud Run. Hopefully you think it's awesome. Give it a try. The place we're at right now is we're just releasing it. So we want everybody to try it out, see what appeals to them most. Maybe it's something we didn't think of, and let us know how that works. What did you try to do, and how did it turn out? So I will have my contact info at the end. I would love to hear from you. Did it work? Like, does it work for you for the problems? Did something come to mind as I was describing it? And if you try that, does it work? OK, next level down. Google Kubernetes Engine, which is just managed Kubernetes. So the thing I've been doing, though, is I've said Kubernetes a lot here, but I never said what it is. And I won't make you raise your hands, but I'm sure somebody's like, WTF Kubernetes. Sorry. So Kubernetes is a management system for running lots of containers. So containers give you this isolation for a process. It sees the same files every time it turns on. Every time you start one up, they see the same exact state. So try to solve that, like, well, it worked on my machine, but it doesn't work over here problem. And if you want to do a lot of those, you end up wanting to do that on lots of machines. And that's what Kubernetes is for. It lets you talk to a whole cluster as if it's kind of one big machine. So you can say, oh, hey, Kubernetes, I want to run 1,000 of those. And it'll figure out where to run them, that sort of thing. And then a whole bunch of features for making that relatively easy to manage, reliable, sensible, troubleshooting, all the fun stuff. And I'll make the claim, I think it's become like a de facto way of doing that, running containers on lots of machines. So Kubernetes Engine is hosted and managed Kubernetes on Google Cloud. So we run the master node for you. We keep the compute nodes up to date, basically kind of moving things off of them and rebooting, creating new ones if they need security patches or what have you. Do the software updates for Kubernetes itself and the underlying OS. And then do integration with things like the load balancer and do cluster auto-scaling to follow the load that you have. So basically makes it easier to operate a Kubernetes cluster. And if you're starting with Kubernetes or interested in getting started with Kubernetes, in my opinion, no matter where you plan on running it, this is a really great place to start. Because you can just, in about 5 minutes, have a cluster up and going, and you're good. You can experiment with it, see if the model works for what you're trying to do, and go from there. So when you're using Kubernetes, you're definitely thinking at a different level of abstraction than we've talked about so far. You're thinking about how different parts of your software talk to other parts of your system. So you might have 5 instances of like a web front end, and 1 database, and a couple of cache servers, or something like that. So it starts to feel a little bit more like a UML diagram, or a diagram you might draw on a whiteboard with your colleagues. And then we express them as these YAML files. But you can actually take these that are computer-oriented descriptions of that whiteboard thing and push them in a cluster and have it actually create that structure, which is really powerful. And you're thinking about the application as a whole, and hopefully not thinking much about how many computers do I have? How do they talk to each other? Because Kubernetes manages how the things find each other, where the processes actually run, and that sort of thing. So it keeps you thinking about the logical connections between your app, and insulates you in many ways from the actual execution environment. So you can run it in different clouds or on your own machines. So that's the key thing in my mind. It's a really good fit for scenarios where you need to run in multiple environments. So you need to have the same thing run on a dev cluster that's on your own machines, but you're going to deploy it to a cloud or 2 clouds. Or you need to be make sure you have the same environment for dev, test, and prod, but you can't have all the same number of machines, that sort of thing. If you really want to take full advantage of containers, go all in, there's just a lot more configurability available in Kubernetes. It does make the most sense when you have really good communications with the other teams in your organization, because you're going to need to have conversations about how things get built, how security patches are going to work, that the ops folks and the devs folks agree on approach and some conventions in places, probably that they can all commit to the same repos to make changes if they need to. And you're probably going to want some sort of build pipeline system to do that collaboration in. And it does give you, like, have processes listening on ports that can talk to each other via load balancing routing. So if you need to do everything I've talked about so far has all been like HTTP, HTTPS, right? So you want to do other stuff, like there's lots and lots of options for connecting the pieces here. Still, you must be in containers. Can be some challenges around licensing where like licenses for some apps are actually per machine. So you have to do some pinning or some special things with labels in order to make sure that the processes always end up on those machines that you've got the licenses set up for. And Kubernetes has an opinion about how things talk to each other. And so that can influence the architecture you decide to do. So Kubernetes engine, can insulate you from a lot of infrastructure. The reason Google's excited about a lot of this stuff is that it enables high utilization, which saves money. You can run the same stuff reliably at higher utilization and not leave a bunch of open headroom for every app individually, because you've got a reliable cluster you can move the processes around on. So you can actually safely and reliably run much higher utilization, which directly equals saved money. The abstractions that it provides are a real sweet spot for a lot of folks. And you are going to have to kind of figure out what you're going to do for logging and monitoring and how all the pieces fit together. So there's that. OK, next level down, virtual machines. So now we're like in the territory of like, we've got an operating system of some kind, and everything above that is up to you, all of it, including like OS patches and the like, which means you can install whatever kernel you want and like additional things you may need to do there. Like if you've got scenarios where you need that, you can do that on these VMs. One thing I want to highlight is we often talk about scaling out in cloud, right? Or lots of little processes and the like. This is an area like they're getting quite large. We just last week announced machines with up to 12 terabytes of RAM. And like I went to another company's retail site and looked for big hard disks that I could order yesterday. And the largest I could find was 14 terabytes. So if you want to go order a hard disk, it's 14 terabytes. Pretty soon, you're going to be able to like just virtually turn on a machine that has 12 terabytes of memory. And so like, probably so yes, there's limits on how far you can scale up, but they're probably higher than we are thinking, right? So yeah. They start very quickly, usually around 20 seconds. We have a bunch of pre-built OS images that are managed in the sense of we make sure that they've got stuff installed on them that makes it easy to use Google Cloud. You can get the on-OS updates systems kind of go through repo mirrors that we have. And so as security patches happen, it all happens fairly locally. So consider those if you can. But you can also you can actually make a block device that is bootable and upload that and boot off of it, right? So you can do all the way down to running whatever you want on these machines. I want to highlight, like, these are virtual machines. They're like CPU, network, disk, and the like, but a lot of the pieces are not so intuitive. So the disks are like the persistent disk, which is our default disk, is a network attached storage. So the block device is actually spread out on like thousands of machines. And they actually compete to return the data back. So the random read that you expect from spinning disk, even though it's spinning disk, it's actually lots of them. So you get a really flat latency instead of a spiky latency on reads. And it's faster than you would think. And because these pages are all spread out all over the place, you can actually take a snapshot of the disk while it's connected with almost no interruption on the machine. There's just a little blip where you need to have a lock for a couple milliseconds to say, this is the most recent block that's there. And then behind the scenes, it can actually copy that all off and make a snapshot of the full disk that you can then restore to make another computer with exactly that data on it. And you can do that anywhere in any of the zones we have. So you can take a snapshot in the US and restore it in Asia or Europe or wherever and do that. And I mentioned to somebody earlier, that leads to some non-intuitive effects that larger disks are faster. And which, wait, what? So bigger disks are actually faster. So if you're doing tests of speed on these VMs, look at the docs and look at the trade-offs, because you need to make sure your disk is fast enough for the IOPS you want. And the reason for that is that disks come with a combined amount of I/O and storage on them, and put those on the data center. And we want to be fair to people who are trying to get all the IOPS possible, and other folks who are trying to store big piles of data. So the two are actually linked up. So if you want the fastest throughput on the disks, you need larger disks. And vice versa. I guess you want lots of storage, you need larger disks too. So pay attention to that when you go do performance testing. And the other piece, these machines come and go really quickly, right? 20 seconds, the like. You don't need Kubernetes to get auto-scaling. You can actually make what's called a managed instance group of identical, you make a VM template, and then it will scale up and down multiple machines, load balance across them, and do that based on the traffic you have or a value you can set in the API. So you can actually scale up a cluster and down very easily. If you're trying to build a disaster recovery site, don't leave all of them running all the time. Have a managed instance group of the front ends running at one, really small one, and then when the disaster actually happens, then spin up all the machines. You save so much money. It's really easy to think of these as a one-to-one equivalence, and I want to encourage you to think of them as being very elastic. And that's true for the individual machines. So you have these groups of machines, but I mentioned these rates, right? You can actually mix and match and have a lot of memory and very little CPU, or the opposite. And you can start with a machine that's very, very small, stop it, change the settings, and reboot it to have 160 vCPUs, right? So it starts with 2 when you're okay, just reboot. Now I've got 100. So it's very, very elastic. Take advantage of that. So when you're using virtual machines, you're using Compute Engine, you're thinking about your software, what's running on the machine. You're thinking about the operating system itself, the disk images, CPU, RAM, disk ratios, the networking, how they talk to each other. There's a lot more moving pieces, but you have control over all of them. There's cases where you really want and need that. So it's all there. So it's a really, really, really good fit for existing systems. So it's almost always the right first step for a system that already exists and you're trying to get some advantages of cloud from it. This is almost always the place to start. You'll get a lot of benefits just moving the machines over. Things like these snapshots to take backups and the like, the networking. There is a possibility of, all I want to do is run a container. I just got this one image, I just want to run it once. As you're starting a VM, you can actually click and say, I want to run this container, and we'll start a container optimized OS and start that one container and just do the one. If you have needs for a specific kernel or OS version, particular license requirements, probably if you're trying to run a database, you're going to be happier here. It's possible to do in some of the other things, but there's a lot more moving parts. And then again, if you've got network protocols beyond HTTP, HTTPS. The scaling is more granular. It's still pretty quick in the big terms, but it takes 20, 30 seconds to start up a VM. You can start lots of them in a minute or two, but there's a granularity there. If you're trying to do really spiky workloads, it might not keep up, and you want to look higher. OK. I'm going to skip the most of the demo, but I can't resist. So there we go. And basically, the way this looks is you pick a name, you choose the kind of balance of kind of preset number of CPUs versus memory, or click Customize and you get these sliders. And you're like, oh, I want this shape machine. And I'll pick a different disk and that sort of thing. So I'm not going to actually do this and log in because I'm trying to say too many things in one thing. But I wanted to highlight down here at the bottom, and this is true for a lot of the UI, there's this little thing that says, oh, what's the equivalent REST or command line? And this will give you the actual JSON that the web app is going to send to the API to do what you do when you hit click, or the gcloud command to do the same thing. So if you explore a flow that you like and you want to automate that, you can actually copy this out, put it in a script, put it on a scheduled task, and go. So it's a really powerful way to kind of learn your way around. OK, so why Compute Engine? You want consistency. You should be able to get the same behavior. I stopped and somebody laughed. Hey, same behavior in test and then later in prod. You get these very custom VMs. You can actually, I didn't even say it, because these disks are block devices, are virtual block devices. You can actually make them larger while the machine's running. So, anybody run out a disk before and had a machine go down? You can actually make the disk bigger while it's on. It's really powerful. We have a lot of things we've done in billing to try to make it really easy to understand. So it's basically billed in small increments, like seconds. And if you just leave it on, we automatically give you discounts. So there's up to like a 30% discount if it runs for a whole month. And by it, I mean number of CPUs and amount of memory on the same kind of general machine shape, not that specific machine. So you can restart them and that sort of thing and pay there. And we have this thing called preemptible machines that are our attempt to get you to think really flexibly, because they're up to 80% discount of the price of a regular VM. They're the same VMs, but they could be stopped within 30 to 60 seconds at any time, and they will not live more than 24 hours. So it encourages you to think about writing your tools in terms of like jobs that come in, do some work, move on, that sort of thing. And if you do, you can just immediately save like a quarter to a fifth of the overall price, just boom. Like it goes down to that, so it's 80% off, like 70 to 80% off. Look at preemptible machines, it's totally worth it. But it will turn off, so make your stuff so that it reboots and works off queues and things. And we use Compute Engine to build a lot of our own services. So a lot of folks here were talking about data. So Dataflow and Dataproc are actually built on top of Compute Engine instances. The managed SQL services we have actually run on top of Compute Engine instances. These are very powerful and really strong building blocks for your systems as well. So, pardon me. OK, I promised to answer this question, right? We've mostly just talked about a bunch of things. So we're back to here. Hopefully these make more sense than they did a little while ago. If in hearing this you're like, oh, that's it, great, start there. But probably we're still in it depends a little bit. So here's some additional thoughts to think about that may push you up or down in between these abstractions. So you may have a different abstraction level you want to work at. There may be some technical requirements you have, or some things about your team, the people you work with, that might like make you want to choose one or the other. So thinking in terms of abstractions, this is just summarizing kind of what I said there. You're thinking about events and functions, or just your code base, or the container format, or the UML diagram of the app, right? Or the actual like representation of a machine. So like, what abstraction do you want to be working at? And it might be different for different problems. You may have technical requirements that are going to push you one way or the other. And in this case, usually down, like the stack. So you're usually going to need to like go below a given abstraction level. So if you need like direct control over URL routing, you want to share code more easily, have more control of versions and traffic splitting, that'll bring you from functions to App Engine. If you need very specific programming languages or environments and the like, that's going to bring you more towards setting up the container to run in Cloud One. You need a specific things from your OS. You're doing hybrid work, network protocols beyond HTTP. That'll bring you probably to Kubernetes. And then you want to just basically own the whole thing. That'll bring you to VMs. There's also billing model differences between these. So like how you plan for paying for them and how it works. So functions, App Engine, and managed Cloud Run are very granular, pay for actual use of the CPU and memory network involved in doing that specific transaction. Cloud Run on GKE itself, so Kubernetes and VMs, you're standing up a set of resources and paying for them while they're on. And then when you turn them off, you stop paying for them. So there's a different model for how you pay for it, how you plan for that payment, and predict what it's going to cost, like how you do that. So that may affect your decisions. The teams you're working on, is it a group of all devs working on a new thing? That's going to have you in a very different place than like, we're trying to keep this stuff working, and we have to, right? My favorite definition of enterprise is it's any environment where most of the applications don't have an application team working on them. Like, you've got a whole bunch of stuff that has to run, but you can't change them. So like, that's going to probably have you start more towards the compute engine side of things. So some balances there. If you're trying to kind of find a mapping of other things, I attempted to make a map of like how you might do similar things in other places, right? So functions as a service, there's lots of, like, I think all the clouds and lots of open source environments have a way to run functions. I struggled a bit to find a clear equivalent for App Engine, maybe something like Cloud Foundry or AppScale, which is an open source App Engine-like environment. Cloud Run is basically, the UX is a little bit different, but the execution environment is Knative and Istio on Kubernetes. So you can run that same stuff there. You can move those workloads very easily. Kubernetes is Kubernetes. So like the environment around it is different, like what you call, but like the same stuff should work wherever you can run it there. And then basically there's lots and lots of options for running whole OSs on virtual machines. So some of these are easier to do hybrid or multi-environment than others. So back to making the right decision and kind of no worries. Hopefully this feels a little more comfortable. So you can definitely use them together. Most real systems use multiples at once. It's not like an all or nothing kind of thing. We have tools that make this a lot easier and better. I won't go into details, so the photos here are probably good. But PubSub allows you to send messages between all of the things. Storage lets you store arbitrary blobs or like data separate from all the things. Cloud tasks are like a queue of things that need doing, and you want to make sure that they all happen, so transactional queue kind of things. And scheduler is cron in the cloud, basically. So at this time, run that, and do that every week kind of thing. So those all help you glue the pieces together, and you can move up and down these. I'll be honest, it's easier to move down in terms of human effort than it is to move up. So if you get things into containers, that gives you more options, and you can move back and forth more easily. And we're trying to make the environments as similar as possible. From all of these environments, you can hit a thing called the metadata server and get tokens for the scope of access rights you have around Google Cloud. So you can always look to there to get your security token for what you're allowed to do, whatever the environment is. You can use Stackdriver from all of them. We've just today announced VPC access, so you can have your App Engine and Cloud Functions show up on the 10.network of your VMs and not like do the public internet loop. And we're working on that for Cloud Run. And here we are back here. So my claim is, if you've got something that looks like these, that's probably the place to start evaluating, and then look at those options. So thank you all very, very, very much.